This six-story building is not a factory or a workshop. It is the engine of the world. S largest LNG-based container ship. It is so huge from the inside that workers can easily walk around in it. This engine drives a propeller as tall as a double-story house. And of course, since this is the engine of a massive container ship, it must consume a huge amount of fuel. But how much, exactly? It gulps down 100,000 liters just during startup. Amazingly, its fuel tank is so big that 6 Olympic-sized swimming pools could fit inside it, and it holds 20 million liters of liquefied natural gas. Today, you will learn about the construction of a mega project that has literally pushed the limits of human engineering. Welcome once again to Think and Grow with Hamden. Ladies and gentlemen, we may be living in the 21st century, but the oceans still carry nearly 90% of global trade, whether it is something as tiny as a sewing needle or as huge as a luxury car. To put things in perspective, Flight Radar shows that at any moment, 15,000 to 20,000 airplanes are flying over our heads. But according to marine traffic, while this video is being recorded, around 38,000 cargo vessels are moving across the world's waters. Humanity has already created some truly gigantic ships. We could build even larger ones, but they wouldn't fit through critical waterways like the Suez Canal or the Panama Canal. That's why the new race ISNT, about who can build the biggest ship. It's about who can build the cleanest and most fuel-efficient one. This is where the French shipping giant CMAC stepped up. Their goal: construct the world's largest, most environmentally friendly container ship, one that would run entirely on LNG liquefied natural gas. Instead of diesel or heavy fuel oil, this beast of a ship stretches 400 meters, roughly the same as laying for football fields in a straight line. It is 61 meters wide, and its height surpasses even the Cutub Minor. Its sheer mass equals 7 Eiffel Towers or 11,500 African elephants. Nearly 70,000 tons, and that's before adding a single container. In total, it can carry 23,312 containers. If you placed those containers end to end, the line would run for 150 kilometers. But constructing one of these monsters wasn't enough. CMAC GM needed 9 of them, and they needed them within just 2 years for this massive job. A 4-kilometer-long shipyard in Hong Kong was selected, a shipyard so large it practically functions like a small city, with 6,000 workers from around the globe working day and night. Normally, a ship of this scale takes 18 months to build. So how did they plan to produce 9 ships in only 24 months? The answer lay in an advanced method: modular construction, using huge prefabricated sections known as blocks. The ship's base is composed of rust-resistant steel plates. These steel sheets were then welded into enormous blocks, some the size of small rooms, others as tall as multi-story buildings. What's fascinating is that each block came pre-fitted with piping, wiring, and other internal systems. The ship's stern, for example, was assembled from 5 massive blocks, weighing 790 tons, the equivalent of 2 locomotive engines. 2 gigantic cranes had to work in tandem just to lift it. Precision was absolutely critical. Even a 1-millimeter error could ruin months of labor. Once the blocks were assembled, the marathon task of welding began. Each ship required 1,250 kilometers of welds, enough to stretch all the way from Karachi to Lahore. Every weld was examined carefully, because the unforgiving ocean exposes even the smallest flaw. But this was only the structural phase. The real marvel of engineering was yet to come: the engine. The ship wouldn't use conventional fuel at all. It was designed to run solely on LNG, a huge environmental breakthrough. Compared to oil-based fuels, LNG produces 99% less sulfur dioxide, 91% less air pollution, and 20% less CO, making sea transport dramatically cleaner. However, this green leap came with a hefty challenge. LNG must stay at minus 161 degrees Celsius to remain in liquid form. If it warms up, it vaporizes, expands, and becomes extremely dangerous. To travel from Asia to Europe without refueling, the ship needed a truly enormous LNG tank. And so engineers built the largest LNG fuel tank ever constructed, with a capacity of 18,000 cubic meters. That's enough space to hold 20 million liters of LNG. But building a giant tank wasn't the hardest part. Insulating it was. Imagine having to construct a thermos, the size of 6 Olympic swimming pools inside a ship. The tank took 9 months to complete, with several layers of insulation protecting it from external heat. Then came a critical step: leak testing. Workers used a surprisingly simple but effective method. They brushed soapy water over each joint, placed a glass container over it, and then used a compressor to suck out the air. If bubbles appeared, that meant a leak. Those joints were repaired and tested again. Afterward, a final layer was applied: a 1.2-millimeter thin flexible steel membrane. At minus 161 degrees Celsius, steel contracts dramatically. The membrane-S wave pattern design lets it shrink and expand safely without breaking the same technology used aboard space stations. After 8 months of work, this colossal, ultra-cold fuel tank was finally complete. Now came the heart of the ship: the engine. It is the largest natural gas engine ever built, standing 20 meters tall, roughly the height of a 6-story building. Weighing over 2,000 tons, it pumps out a mind-blowing 85,000 horsepower. It's so huge that technicians can actually walk inside it. Transporting this engine to the shipyard was another engineering feat. It arrived in 6 separate pieces. The most critical piece, the crankshaft, weighed 220 tons and had to be moved on a remote-controlled platform equipped with 140 wheels. The engine houses 12 pistons, each 1 meter wide, all connected to the crankshaft, which turns the main propeller. The propeller itself is a masterpiece, a single piece cast weighing 92 tons and towering 10 meters 33 feet high. For it to operate smoothly, the propeller shaft must be perfectly straight. Even the smallest flaw could cause violent vibrations at high speed. Engineers applied a blue dye to test the contact points and fine-tune the alignment. After the whole structure was assembled, the ship needed protection from the harsh saltwater environment. A special marine coating was applied. 1 million liters of paint covering 9,500 square meters, which is double the size of Vatican City. Finally, the last and tallest block was installed: the command bridge. This is essentially the ship's brain, where the captain and crew control every operation. The ship is fitted with an advanced system called Smart Eyes, giving a complete 360-degree view from the bridge. After 18 months of non-stop work, the first ship, Jacques Sade, was ready for testing. It underwent 15 days of extreme sea trials, speed checks, emergency stopping tests, navigation verification, leak inspections, and anchor deployment. A single link of its anchor chain weighs 300 kilograms, and the full chain weighs as much as 60 African elephants. The trials were successful. The engineer's vision of a low-carbon shipping fleet had finally become reality. The shipyard achieved what seemed impossible: 9 megaships delivered in record time. This isn't just a tale of assembling a steel giant. It is the story of thousands of skilled workers, their expertise, and their unwavering commitment. These ships are now ready to dominate the world's oceans, and do so in a far cleaner, greener way. These engineering marvels prove one thing: when humanity sets its mind on a challenge, even mountains of steel can be made to glide across stormy seas. Thank you for watching. Stay tuned for more fascinating stories in the next video.